So this is section 10.2, operations with matrices. We talked about matrices yesterday. We've got equal matrices, what we're talking about first. And so this matrix has 3 rows, and it has 4 columns. So it is a 3 by 4. This one is also a 3 by 4. It also has 3 rows and 4 columns. So for you to have 2 equal matrices, they have to be the exact same dimensions, because every element over here has to have a corresponding element over here. So 4 has a corresponding element over here, and 5 has a corresponding element here. And then that's where we get into the fact that here I have 2 elements that the first 2 that I circled, 16 and 16, they were the same because these are equal matrices. The second elements I circled, 4 and 4, they were the same. So the third pair has a variable in it. So they also have to be the same. So since we have equal matrices, I can set those expressions equal to each other, and I can say that 2x plus 1 has to equal 5. Okay, you can see in other cases 4 and 4, negative 3, 13, 15. Then I've got the 6 and the 3x. So here I've got 6 and 3x that correspond with each other. So 3x also has to equal 6. These both have x in them. Do you think x can be 2 different values within the same problem? No, it has to be the same. So even though it shows up twice there, if it shows up twice, they should both come out to be the same answer. And the only other place I have a variable is with this 4 and the 3y minus 5. Now, in this example I've given you, it's very simple. What you set these equal to each other, you have linear equations. You've been solving those since you were in like pre-algebra probably. Okay? It should be equal to 4. So these are going to be a lot easier to solve, but what you could end up, if you're doing a problem like this, is you might end up with a couple of equations that maybe this equation has x and y in it, and then maybe this one has x and y in it, and so then you'd have to use them together as a system and use substitution or elimination or row echelon form or something like that. All right, in this case, pretty easy to solve. 2x is equal to 4, x is equal to 2. Solve this one, you get x equals 2 as well. As I said before, those should be the same value either way. This one, 3y is equal to 9, now that I have it correct, equal to the correct value over there, and y is equal to 3. Okay? So this is one type of operation that you might see with matrices, where you have 2 matrices that are equal to each other. We have, it's just me doing the exact same thing. We have other operations with matrices. So there's addition, subtraction, scalar multiplication, and then we'll finally get to another operation which is called just matrix multiplication. Scalar multiplication, a scalar means it's just a single number. So a scalar means you're taking like 5 and multiplying an entire matrix by that number. So these are just a few notes that I came up with just to kind of remind you of what you need to be looking for. When you're adding or subtracting matrices, they have to be the same dimensions. So you can't take like a 2 by 3 and a 3 by 2 and add them together. If you're going to add 2 matrices together, they have to both have the same exact number of rows and columns. And then all you do is you perform your operations on the corresponding elements. So whatever's in row 1, column 1 of the first matrix, you're adding it to the other matrix, you're going to add it to row 1, column 1's element as well. Scalar multiplication is a lot like the distributive property. It's basically just a number that you're going to multiply all of the elements in your matrix by. And so that's where you have a single number times a matrix. Your answer will be the same dimensions as the original matrix. So I do have a few examples that we are going to go through to kind of show you that's going on now. So first of all, this says find for part A plus B. Can I even do that? What's the dimensions of A? A 2 by 2. What's the dimensions of B? It is also a 2 by 2, so I can add those together. Okay, so A plus B, since they're both 2 by 2s, my answer will also be a 2 by 2. So that means it has 2 rows and 2 columns. And you're just taking corresponding elements. So 1 and negative 3. How much work you show on this is just going to depend on how involved it is. for this, I wouldn't show a whole lot of work. 1 plus negative 3 is negative 2. And then when I take 2 and negative 2, those correspond, so that would be added together as 0. This 2 and this 4, they are corresponding elements in the same location. So 2 plus 4 is 6. And then you got the 1 and the 2, they correspond with each other, so that answer would be 3. When you do the subtraction one, it's just the same thing. Just be careful with your subtraction. So if I'm doing A minus B, again, they're both 2 by 2s, so I'm going to get 4 elements for my answer. Just be careful when you're doing your subtraction. If I'm taking A minus B, it's 1 minus a negative 3, so that's going to be a positive 4. 2 minus a negative 2 is a positive 4. 2 minus 4 is going to be a negative 2, and 1 minus 2 would be a negative 1. For the part C, when you're doing 5A, that's an example of a scalar. So when you see a number right next to a variable, or what looks like a variable, it's actually a matrix, you're just taking every element up here times 5. So 5A, you'll see it sometimes written like this, 5 times, and then you've got the original A was 1, 2, 2, 1. You can see I was real creative with my matrices. I created them. But you're just distributing. So the answer for this would be 5, 10, 10, 5. So hopefully you're working ahead on me on this. For part D, it has 2 different things going on there. I have scalars and I have subtraction. It's a lot like the order of operations. You can't just assume that it's going to be the same as other operations you do, but in this case, the order of operations that you are used to is the same for matrices. So you would multiply those by the scalar first, and then you would subtract. So you might want to do that as a couple of separate steps. This is where you might think, well, the math is really simple, but it'd be really easy to mess this up. So if I'm taking 4 times A, that would be 4, 8, 8, 4, and then minus, and then 3 times B, so that would be negative 9, negative 6, 12, and 6. Now, notice, I have the minus sign still here. Frequently, the mistake I'll see students do is they'll think of this as being a negative 3. That's fine. You think of that as being a negative 3, and you distribute these by, and multiply all these by negative 3, and get positive 9, positive 6, negative 12, and negative 6. That's okay, but once you do that, this would be a plus sign here because you've already used your negative. So just be careful if you're going to do that. I don't have a problem with you doing that. Just don't use the negative sign twice, is basically what I'm trying to tell you. Okay? So for this one, you should have 4 minus a negative 9 would be 13. 8 minus a negative 6 would be 14. 8 minus 12 would be a negative 4. And 4 minus 6 would be a negative 2.